Hello class, welcome to another video for this chapter, and we are going to study section 6.2, graphs of other trig function. So far, we looked at the graph of sine and cosine function, but we learned more trig functions such as tangent, cotangent, sine, secant, and cosecant functions. So now let's look at their graph. Let's start by tangent. So tangent, maybe I start with some values. So we are going to look at the graph of tangent function. Okay, so we are going to look at the graph of tangent function. And so recall that tangent is in fact sine over cosine, and we already know a lot about sine and cosine. That's good to remember. But we can also look at some table of just some of the values. For example, let's look at angle 0. At 0, what is tangent? Okay, so we know that sine of 0 is 0, cosine is 1, so tangent is going to be 0. So that's going to give us, I mean, graphically, I'm going to draw the graph at the same time. X-axis, y-axis. So at 0, it's 0, right? At 0 is 0. What else? Let's look at, for example, pi over 4. At pi over 4, sine and cosine are the same value. So when you divide them, you get 1. So at pi over 4 is 1. So that's going to give us this point, right? What else? So as you increase the values, the tangent, as you increase the angle, tangent is going to increase. As for example, at pi over 6, as pi over 3, we know that sine is a square root of 3 over 2, cosine is half, so this is going to be a square root of 3. So at pi over 3, tangent is going to be 1.7, something like that, right? And so on, up to pi over 2. So the values, as you increase the value, as you increase the angle, the output value, the tangent value is going to increases. But when you reach pi over 2, what happens is that sine of pi over 2, look, sine of tangent is sine of pi over 2 over cosine of pi over 2. So what is sine of pi over 2? It's 1. What is the cosine? It's 0. So this is undefined. I mean, remember, denominator cannot be 0. And if this happens, whenever denominator is 0, we have the vertical asymptotes, which means that it's like going, this value is so large, it's like going to infinity. So at pi over 2, there is a vertical asymptote. I'm going to draw that vertical asymptote. And you can see that as you increase, you can try more values. As you increase the, so look, it's at 0, then it goes 1, square root of 3. So as you increase the angle, the output value gets larger and larger and larger, and it's like it approaches this vertical asymptotes, but it never crosses it because there is a so this is gonna be a vertical. So pi over 2, maybe use a color, another color. So this is the line of pi over 2. So this is going to give us the vertical asymptote, right? And actually, it happens even for the negative ones. So you can try any value that you want. So maybe I go further. For example, after pi over 2, you can look at any other value, like, but you can try more values to see that then suddenly it's very negative, it's very small negative numbers. The reason is that in unit circle, look at the unit circle. So here is 0, here is pi over 2, after pi over 2, so somewhere like here. It's the division, tangent is the division of sine over cosine. So you have a large sine, so that's why you're gonna have a large tangent. But the thing is that because the sine is positive, cosine is negative, that's why you end up with a negative number up to pi. Okay, so I'm gonna also try pi. So at pi, sine is 0, so it reaches 0. So your graph is gonna be something like this. Why it's not doing? So it's gonna be like this up to pi. So it comes to here up to pi. This is pi. And then after pi, this is pi. After pi, for this value, it gets larger and larger. And again, at 3 pi over 2, so I'm going to put 3 pi over 2. What happens is that, again, sine is -1, cosine is 0. So again, this is undefined, undefined. So again, we get a vertical asymptote. So at 3 pi over 2, this is 3 pi over 2, we get a vertical asymptote. And this happens over and over. So in fact, because any multiplier of pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, and so on, because for all of them cosine is 0, so the denominator is 0, so we get the vertical asymptote. So the repetition is like this. The behavior of this function is like this. Let me complete the graph. So all the vertical asymptotes are at pi over 3, and then here you have 2 pi, here you have 5 pi over 2. So again, here you have a graph. Look, here also you have a vertical asymptote, and the graph is gonna be like this. And also here, this is negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. These are all vertical asymptotes because at these values, denominator is 0. And we have the graph, we have the repetition of this graph over here. So that's the graph of tangent. You can, if you want, you can try more values, see more input-output values, and then connect them to see why we get to this. And pay attention that this is a periodic function because it's like, look, you have a complete rotation. Look, from here to here. Maybe use another color. Look, a complete rotation is between here to here, from negative pi over 2 to positive pi over 2. So that's it, pi. So period is pi. Period is pi. Why? Because it's like after each pi, we repeat the same thing. You see, it's like you draw a graph and then you have copies of the same shape after each pi. So these are the characteristic of tangent function. So as you can see, you have, because sine is 0, you have zeros at negative pi, 0, pi, and so on. And then because the denominator, cosine is 0, at the denominator becomes 0 at negative pi over 2, pi over 2, 3 pi over 2, and so on. So that gives us the vertical asymptotes. To summarize this, so the graph of tangent has a period of pi. The domain is everything except these multiplier of pi over 2, which gives us the vertical asymptote, like pi over 2, 3 pi over 2, 5 pi over 2. So we don't accept these multiplier of pi over 2. And the range is everything, okay? So that's the graph of tangent. If you want to, anytime you want to verify that, you can also look at graphing calculator, use a graphing calculator to see to see the better shape, more accurate shape of the graph. So we are looking at tangent function, tangent of x, okay? So as you can see, the graph is like this, you see? This is a periodic graph. Why? Because it's like when you have a full rotation, okay, over a full rotation, we draw a curve. And then after that, when you repeat this rotation, we just repeat the same shape. So it's like it's like a horizontal shift, or it's like drawing a copy of the same shape over and over. And what is the period? Period is pi, which means that we draw the curve into the interval of pi, and then after each pi, we just repeat the same thing over and over. And as you can see, there are vertical asymptotes as well. The vertical asymptotes are at the multiplier of pi over 2, like pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on, and also for the negative one. Okay, so that's about tangent. Okay, find the formula, example 1, find the formula for the graph here. So this graph looks like a tangent function, right? And I want to write something on the picture. So I'm gonna, okay, so here, this is like a tangent function. So this is a transformation. So I can see that f of theta is a transformation of tangent function. But we just need to figure if there is a stretch, if there is a shift, if there is a stretch, and so on. Okay, so first of all, let's find the period of this function, okay? What is the period of this function? When I look at this graph, I see that there are vertical asymptotes here and here, right? So one full rotation, so these are the vertical asymptotes, and one full rotation is over 4 units. You see that? 4 units. So what does it mean? It means that period of this function is 4. Okay? So I know if this tangent of theta, right? So because period, we know that for tangent, the period is pi. But this transformation of tangent has a period of 4. So that means there was a multiplier. The input value had a multiplier. What was the multiplier? Recall, the multiplier is the period divided by what is the period of tangent? So maybe I write it this way: period of tangent, period of okay. So we want to find a multiplier, right? It's gonna be the original period, something period of tangent function, or original period divided by new period, or transformed version function period, something like that. What I mean here is that it's a division of original period is the period of tangent function, which is pi. Now, what is the period of this new function? It's 4. So multiplier is it 4 or, oh, I'm sorry, it's 8. I'm sorry, this is 8 units. 4 to the right, 4 to the left, it's 8 units. So period is 8. This distance is 8 units. The distance is 8 units, so period is 8. So divided by 8. Okay, that's the multiplier. So the multiplier is pi over 8. There is no vertical shift. I can see that from the graph, there is no vertical shift. But what about the stretch? Is there any stretch on this graph? I don't know. Let's figure. If there is a stretch, so we can put a letter to represent the stretch value, and then we can pick a point from the graph, substitute that point into the function, and solve it for A to find the stretch. For example, one point is this point, 2 and 2. So substitute 2 and 2 here. So it's gonna be 2 equal A tangent of pi over 8 times 2, right? So I substitute 2 and 2 here. So this is gonna be 2A tangent of pi over 4. Tangent of pi over 4 is 1, so A is 2. A is 2, that's it. A is 2, so the answer is 2 tangent of, so the answer is, this graph has the equation of 2 tangent of pi over 8 times theta, okay? So we learned about the graph of tangent, and also because we know transformation technique, so we can also derive transformed graphs from tangent. Now, the other two functions were secant and cosecant. Do you remember secant function? Do you remember secant, which was 1 over cosine? That was the way we defined secant function. Secant function is 1 over cosine. So let's look at some of the, So let's look at a table of value, not a complete table of value, just a couple of points. So secant is 1 over cosine. So looking at some of the values, so theta, secant of theta, for example, at 0. Okay, at 0, it's gonna be, cosine is 0, so it's gonna be, this cosine is gonna be 1, so it's gonna be 1. What about pi over 2? Okay, at pi over 2, so what happens is that at pi over 2, cosine is 0. So here is the case that the denominator, so it's going to be 1 over 0, right? 1 over 0. This is undefined. Denominator is what? Denominator is 0. So that's going to give me a vertical, this is going to give me a vertical asymptote because denominator is 0. What else? Let's plot this. Let's put this already. So we know that at pi over 2, there is vertical asymptote. What are the other vertical asymptotes? So this is 1 over pi over 2. So cosine becomes 0. Cosine becomes 0 at, let's try a couple more values, like pi, like 3 pi over 2, and 2 pi, for example. So at pi, this is going to be -1. At 3 pi over 2, again, we get a vertical asymptote because it's going to be 1 over -1 over, it's going to be 1 over 0. So at 3 pi over 2, so this is, let me put this here, 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? So we have vertical asymptote at 3 pi over 2. And by the way, at 0, the graph is 1. So it's right here. At 0 is 1. At pi is -1. This is -1. At pi is -1. And at 2 pi is again 1. So at pi is again 1. So because so first of all, look at the vertical asymptote. Any multiplier of pi over 2, not any multiplier. Multiplier like half, 3, multiply odd multiplier of pi over 2, like 1 pi over 2, 3 pi over 2, 5 pi over 2, and also here negative pi over 2, negative 3 pi over 2. All of these are vertical asymptote of the graph. What else? What is the behavior of function, for example, in between these vertical asymptotes? So it's 1 over cosine. Secant is 1 over cosine, right? So, and we know that like cosine, for example, let me show you a couple of more points. I think it would be good to look at a couple of more points. For example, pi over 3 or pi over 6. So I'm going to show you pi over 6, for example. So pi over 6, so it's 1 over cosine. What is cosine? Cosine of pi over 6 is half, so it's going to be 2. So at pi over 6, it's going to be 2. So I see that if you try more values, you see that the graph is increasing. You see what I'm saying? You can try at 0 is 1, but as you increase the angles toward pi over 2, the graph is increasing and approaches the vertical asymptotes. And also you can try some values toward the negative sign. For example, at negative pi over 6, it's also 2. Right? So you would have this, if you try more values, you see you have this shape, right? And between these vertical asymptotes. What about over here? For example, at, let's look at one point. For example, at pi over 4. So it's 1 over a square root of 2 over 2. And because it's cosine, this is negative. So it's going to be negative 2 over a square root of 2. So it's going to be somewhere like here. And you can try more points to see that its points are here. And then you can try more point to draw this. So the pattern is that we have a repetition like this. So it's like we have copies of this between our vertical asymptotes. If you try more points and then connect them, you can see that the graph of secant is like this. And you have the shape in your textbook as well. So secant is 1 over cosine. By the way, in this picture, the blue, the graph in blue is the graph of secant, and that dashed red graph is the graph of cosine, because I wanted to show you because secant is defined based on cosine. There's a relationship between secant and cosine, and this image wanted to show you the connection between these two graphs. So as you can see, this is the graph of secant. What is the period of this function? Let's see, it's pi. Is it pi? No, sorry. It's actually 2 pi, because the period is, so you have this and this, right? And then you keep repeating the same thing. So you have this, and then you have this, and then you keep drawing the same thing. So that's the whole time to take a full rotation is what? It's 2 pi. So period is 2 pi, okay? So it's like I can continue this so you can have a better clear picture. Like, look, so the next one is gonna be here. And then you have this and this. So the next one is going to be this and this, and so on. So this is the pattern. And it's repeated in each 2 pi. So period is 2 pi. So to summarize it, the secant and you can also try cosecant. Cosecant, most of them have period of 2 pi, like sine and cosine. What is the domain? The domain is everything except those vertical asymptotes. And in this case, oh, by the way, this is the image of secant, and you can also look at the image of cosecant. Okay, and so the domain is everything except those values that are the gives us the vertical asymptote, and both of them have a range from negative infinity to -1, and then 1 to infinity. So they don't give us any value between 1 and -1. I think I think mm, you know, I think if you just get the idea of secant and cosecant, things like this is just transformation. You know what is the transformation. So you just draw cosecant function. So your base original function is, for example, cosecant, and then the 2 gives you the stretch, vertical stretch for 2 units. Pi over 2 is the multiplier, so it's gonna have a new period. So what is the period? Maybe I just show you the period of this function. So, okay, I'm going to show you this one. Let me show you this one. This is example 2. Example 2, and the function is f of theta is 2 cosecant of pi over 2 theta plus 1, right? So first of all, the question is, what is the domain and range of this function? Okay, I'm gonna actually say more about this. What is the domain and range? Okay, so this is, look, this gives us a stretch. This gives us a vertical stretch for 2 units in terms of transformation. This is gonna give us a new period, and this is gonna give us a shift, vertical shift. But the question asks about domain and range, right? So it can take any domain. Let's first talk about domain. What is the domain? So first of all, it can take any angle except those who give us the vertical asymptote, right? And this is cosecant. So what is for cosecant? Let me say that cosecant is 1 over sine, right? So what are the vertical asymptote? Any place that makes sine 0. What are the places that makes the sine 0? I'm gonna draw cosecant. So it's not the question, it's just in general cosecant. So at what value sine is 0? Sine is 0 at pi. Sine is 0 at pi. So we are gonna have a vertical asymptote here. Sine is 0 at 2 pi, and so on. So then 3 pi, 4 pi, and also same thing for the negative side. So we are gonna have vertical asymptotes over here, right? And also -1, negative pi, negative 2 pi, negative 3 pi, negative 4 pi, and so on. So these are the vertical asymptote for cosecant. And then the graph, I'm gonna draw the graph quickly. So sine is like this, right? Sine is like this. What is this? This is sine function. So cosecant is gonna be like this. Oh, by the way, I forgot another vertical asymptote, 0. We also have vertical asymptote at 0. So, so it's gonna be like this. This is the graph of cosecant. So this is the graph of cosecant, right? Now, this question is just this example, f of theta is just a transform version of cosecant, right? What is the domain? Okay, domain is everything except the vertical asymptotes, right? For cosecant, domain is everything except 0, pi, 3 pi, 4 pi, and so on. But I think here, what makes it 0 is like, look, so for example, at 0, look, if theta is 0, then pi over 2 theta is also 0. Okay. But then, like at pi, you're gonna multiply pi by pi over 2. So this is not gonna give me anything like, the idea is that, look, so we know that domain of cosecant function is everything except a multiplier of pi, k pi, right? Which is gonna be like 0, 2 pi, 3 pi, 4 pi, and so on. So it's gonna be multiplier of pi. So now domain of this new function, domain of f of theta is gonna be everything except when the input value is multiplier of pi. You see, because here we have the input value is pi over 2 theta. So whenever this input value becomes 0, becomes pi, becomes 2 pi, 3 pi, and so on. So in other words, when theta is 2k, if you simplify it, when theta is 2k. So in other words, when theta is k is any number like so 0, 2, 4, so 0, 2, 4, 6, and so on, right? You can also try that to see, for example, when you look, when you substitute 0, when theta is 0, then the input value is gonna be 0, and you get the vertical asymptote. When theta is 2, pi over 2 multiplied by 2 gives us pi. That's a vertical asymptote. When theta is 4, pi over 2 times 4 gives us 2 pi. That's a vertical asymptote. But theta is 6, pi over 2 times 6 gives us 3 pi. That's going to give us the vertical asymptote, okay? So domain is everything except 0, 2, 4, 6, except even numbers. So domain is everything except even numbers, okay? And what was the next question? And what is the range? the range of this function is, so maybe I draw it. How about that? Maybe I draw the graph. The graph of this function. So here I'm gonna draw this graph, okay? So it's a cosecant function, and we learned that, not x, this is gonna be theta. 0, we have the vertical asymptote at 0, 2, 4, 6, 8, and also the -1. -2, -4, -6, -8. Here are the vertical asymptotes, okay? So we have the vertical asymptotes here. And then there's a stretch, okay, for 2 units, that's okay. But there's a vertical shift as well. We need to shift it 1 unit up. So look, the original function is between 1, you see, this is 1. So when you shift this up from 1, we should go to 2. So draw the same thing, but instead of 1, draw it at 2. So this is gonna go here. Oh. So shift, my point is that shift that graph 2 units up. So this is gonna be here. Okay. And then here, 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 okay? And then also we need from log, because this is -1. When you shift it 1 unit up, it goes to 0, right? So the other one also needs to be drawn from here. This is gonna be a rough sketch of this graph. So this is f of theta, y equal f of theta. A rough sketch of this graph. And what is the range? Oh, I forgot. The question was, what is the range? So range is gonna be the range of this function. The range of this function is gonna be from -infinity up to 0. So it goes from negative up to union. Then it takes no value between 0 and 2, and then it's go from 2 to +infinity. So you see, it doesn't give us any value between 0 and 2. So domain, one more time. Domain is everything except even numbers. So everything except 2, 4, 6, 8, and also -1s. Range is everything except 0 and 2, values between 0 and 2. And here is a rough sketch. Did I say it correctly? Let me see. The vertical search of 2. Let me see. The basic sine graph has a range of -1. The vertical stretch by 2 gives us -2 and 2. Oh, I didn't incorporate this. I see. And the vertical shift up to 1 units is -1 and 3. That's what I saw. Okay. If this is too much, another way, I mean, let me tell you what went wrong. So because I tried to sketch it by hand to see what is the range, we need to be more careful. I didn't incorporate the multiplier, the stretch multiplier, and when I was drawing the graph. So maybe to get the range, if we want to save time and have a more accurate graph, maybe we use the calculator. Maybe this would be better. Use the graphing calculator and then draw the function 2 cosine of 2 cosecant of pi over 2 theta or x plus 1. This would be, one more time. So the graph is 2 cosecant. Okay, so the graph is 2 cosecant. Oh, I think the cosecant maybe is not defined here. Okay, that's fine. If it is, let me see. If I, yeah, it's defined. So this is the cosecant. Okay, it's multiplied by 2. And then here we have what? We have pi over 2x plus 1. Yeah, I think this is there. Yeah. Let's save some time and avoid any mistakes. So this is the graph. So just draw the graph using a graphing calculator. Now look at the graph to determine the range. What is the range? Range is everything except the values between height -1 and 3. Yes, what is the reason that mine give me something different? Because I didn't incorporate the multiplier tool. That's why. So, okay, so it's gonna be from negative up to -1 and then from 3. Okay, but the domain is the same thing. So as you can see, domain is everything except those vertical asymptotes, and we have those vertical asymptotes at even numbers. And range is everything except the values between -1 and 3. And this is the graph of this function. Okay. So I think, the last function that we need to look at is cotangent. Cotangent is, we defined it as the ratio of cosine to sine. Do you remember? Ratio of cosine to sine, or invert the, if you flip the tangent, it gives us the cotangent. So for cotangent, which is cosine over sine, where do we get the asymptotes? We get the vertical asymptote whenever sine is 0. So when is sine is 0? Cotangent of theta. Sine is 0 at 0. So it's going to be 1 over 0. That's give us the vertical asymptote. And then pi over 2, pi, 3 pi over 2, 2 pi. Let's look at a couple of these ones. So this is also going to be, so what are the vertical asymptote? The vertical asymptote, this is going to give us a vertical asymptote because denominator is 0. This is going to give us a vertical asymptote. Oops. Sorry. This is because this is over 0. Sine is 0 at this and this one. These are the vertical asymptotes. So the domain is everything except these vertical asymptotes. And if we want to draw the graph, so we're gonna have vertical, let's say this is pi over 2, pi, 3 pi over 2, 2 pi, and also same thing here, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Vertical asymptotes happen at 0, at pi, at 2 pi, So because sine is 0, the denominator becomes 0, or sine becomes 0 at these angles. So these are the vertical asymptotes. And then, for example, at pi over 2, cosine is 0, sine is 1. So that gives me the 0. And here is so 0. You can try more values. So here is 0, here is 0, here is 0, here is 0. I recommend you to try more values to see that the graph is like this. So again, this is a periodic function. Domain is everything except odd multiplier of pi over 2, and range is everything. And period is, what is the period? We complete one rotation in pi. You see? So period is pi. We get repetition after each pi. So that's a graph of cotangent. So what are the features of cotangent? Has a period of pi. Domain is everything except multiplier of pi, such as domain is everything except 0, pi, 2 pi, 3 pi, 4 pi, and also the negative ones. And range is everything. And also you can, okay, so it's easy. The next point is just about being odd function. It's so easy to see that tangent, cotangent, secant, and cosecant, all of them are odd function. It's so easy. Look, to see that they are odd function. For example, tangent of negative theta. So rewrite tangent as sine and cosine. Tangent is sine over cosine, right? And then we know that sine is odd, so this is going to be negative sine of theta. And we know that cosine is an even function, so it's going to be cosine of theta. Then we know that this is tangent, so it's going to give us the negative tangent of theta. You can use the same argument to see that all of these function, tangent, cotangent, secant, and cosecants are odd function. So now let's just look one more question. Prove this identity. Okay, prove this identity. Prove that tangent of negative theta is negative cotangent of theta minus pi over 2. So prove this. Okay, so we know that tangent of theta, not negative theta, I'm sorry. Tangent of theta. So we know that tangent of theta is sine over cosine. Right? And then maybe I explain it from here. So we know that tangent is sine over cosine. And then the relationship between sine and cosine is this. So sine can be replaced by sine is the identity that relates sine and cosine is the cosine of pi over 2 minus theta, and cosine is sine of pi over 2 minus theta. In this way, in this ratio, why did I use this? Why do we use this identity? Because in this way, we switch the place of cosine and sine, which make it closer to cotangent, because cotangent on the right side is cosine over sine. Okay, now this is gonna be cotangent of pi over 2 minus theta, because cotangent is cosine divided by sine. Now, so if you factor negative sign, we can factor a negative sign from here. It's give us this, right? Now, we know that cotangent is an odd function, so it's going to give it out, give the negative sign out. And I think we are done, right? We got to the right side. Yes. We proved that tangent of theta is negative cotangent of. So we just use a couple of identities to show this relationship. Yeah. So for now, just as long as you know the graph of tangent and cotangent, what is the period, domain, and range, and the same thing for secant and cosecant, and be able to understand the transformation and also know that negative identity, you should be good. So now you are ready to do the exercises of this section. Thank you for watching this video. I'll see you in the next one.